Welcome to this EuroLEAN Plus video lecture. Today, we will give a short overview of material requirements and resource planning. We will present and discuss strong and weak points of the system. In 1964, Joseph Orlicki developed Material Requirements Planning, or MRP. The first company to use this was Black & Decker. Consider the situation of a company which has three departments: part manufacturing, a sub-assembly department, and final assembly. Let us zoom in on parts manufacturing. Some of the parts need many processes to be performed by a variety of machines. Other parts are more simple and only need one process. At some machines, long changeover times are needed when the machine has to switch from one product to another because the items and parts are different. According to MRP, these items require different treatment. For example, some items need to be produced in large batches in order to save changeover time. It is natural to produce these items on stock. Another example is that some items need many processes in the department. The lead times for these items need to be longer than for the items which only need one process. MRP respects the differences between these items. In order to treat every item differently, MRP makes use of software to create linkages between the demand of final products and the jobs to be done at the work floor. First, MRP makes use of an aggregate production plan, which concerns the ambition of the company with respect to the demand for each of the product groups. Based on this aggregate plan, the company invests in buildings, machines, workers, etc. The master production schedule gives information about the need for each product in a particular product group over time. Firm orders from customers and forecasted orders are the input for making the master production schedule. MRP1 uses the output of the master production schedule for calculating the need for subassemblies and parts in the course of time. In order to calculate this need, MRP1 needs information from the bill of material, which shows how final products are built up from subassemblies and, subsequently, how the subassemblies need parts. Furthermore, MRP1 needs information about the inventory of subassemblies and parts. If there is sufficient inventory on stock, then no manufacturing or subassembly is needed. If, however, there is a lack of needed items, then manufacturing orders or purchasing orders have to be created by the planning department. Here you see an example of the bill of material. In this case, final product A needs 4 subassemblies of B and 2 subassemblies of C. B needs 2 parts D and 1 part E. C needs 3 parts D and 2 parts F. This information is used in the so-called MRP scheme. Here you see a very simplified scheme. It shows that the master production schedule asks 60 products of type A in week 10. Because the final assembly takes 2 weeks, sufficient subassemblies of B and C need to be present in week 8. The subassemblies of B and C require respectively 2 weeks and 1 week. This triggers the need for a timely presence of parts D, E, and F. Also, the manufacturing of these items require time. It is interesting to see that the order placement of subassembly B in week 6 is not 240, but 300. The reason for this is that the minimum batch quantity of this subassembly is 300. By using a minimum order quantity, we may save changeover or setup times. On the other end, we will create some additional B subassemblies on stock to be used in later final assemblies. Another interesting thing is the order placement of part D in weeks 1, 2, and 3. We would expect respectively 360, 0, and 480. The scheme tells us that 200, 0, and 460 is sufficient instead. The reason for this is that the stock position of part D equals 180 items at the beginning of week 1, and the minimum quantity equals 200. So, at the beginning of week 2 and 3, there are 20 items of D on stock. Therefore, a manufacturing order of only 460 items needs to be placed in week 3. Calculating the requirements across many different products will get quite involved, so MRP requires computer software to manage it all. What are the advantages and disadvantages of MRP? Let's start with the advantages. MRP recognizes that items and subassemblies may be needed in different final products and integrated the demand for these items and subassemblies. Furthermore, each item and subassembly gets individual treatment and have their own lead times and minimal batch quantity. All information is stored in the computer. It is a starting point for further optimization. As well, MRP supports the necessary communication between the various departments in a company, such as manufacturing, sales, and purchasing. However, MRP does have some disadvantages, which is the reason why many just-in-time adepts do not like MRP. First, the computer assumes that all its information is correct. In reality, many times there are differences between the real stock position and the amount mentioned in the system. MRP asks for discipline at the work floor. Operators need to inform the computer about the use of materials and items and the timing of their activities in order to keep the system accurate. Most MRP systems run once a day. In the just-in-time philosophy, planning should be more integrated in workflow activities. Next, MRP calculates the need for capacity. It does not consider available capacity as a means to speed up or slow down activities or to change batch sizes. As well, since MRP makes use of the concept of minimal batch sizes in order to avoid relatively long changeover times, the lead times of customer orders may be very long. Finally, if there is a small change in customer demand, the whole MRP scheme may change. MRP is a nervous system. As a key principle for planning and control for high variety, low volume, we note that MRP taught us that the use of computers and information technology is useful for the coordination of activities in the company. However, we also got the lesson that we need to be careful in using this information for optimization purposes. The individual treatment of items and subassemblies and the trade-off between inventory costs and the cost of setup time may lead to unprofitably long lead times. Thank you for watching this overview lecture on material requirements and resource planning.